So now on this next problem where I'm finding the exact area myself, and they give me the range, or I should say actually the domain values for x. So now I want to use my limit formula because it gives me the exact area. Remember, that's what this formula does, is find me the exact area. So I'm going to need to know f of x sub I, like I did previously when I was doing the left and right endpoints, and delta x. So if you remember, delta x was b minus a over n. So here's my beginning point of the interval, and here's the end value of the interval. So delta x will be 1 minus 0. And so now, since I don't know how many rectangles, it's unspecified, it's going to infinity, I'll just put an n down there. So delta x is 1 over n. And then remember, x sub I, to find any particular x value, I have to know where I started on the interval. So in this case, I started at 0. And then I'm going to add a whole bunch of these delta x's I times. Remember, I is going to change. Like I could be 1, so I would add it 1 time. Or I could be 2, so I would add that delta x 2 times. Or I could be 3, so I'd add that delta x 3 times. It's how many times, how many rectangles over I'm moving from the first value on the interval. Hopefully that makes sense. And then f of x sub I, well, I knew what f of x was. It was x cubed. So if I want to find f of x sub I have to just plug in x sub I. So that'll be x sub I. Just kidding. Sorry guys, I was losing it. So of course I know what x sub I is. It's this 1 over n times I. So I would be doing f of 1 over n I, which is 1, or I could say I over n cubed, or I cubed over n cubed. And now I can plug that into my exact area formula, which is the limit as n goes to infinity of the sum I equals 1 to n. And remember, it's f of x sub I, those are the heights of the rectangles, times delta x, which is the width of the rectangles. And so now I have f of x sub I, it's right here. So I have I cubed over n cubed times, and I know delta x is over here, which is 1 over n. So if I simplify this, still have the limit, haven't done anything with that yet. Still have the summation, haven't done anything with that yet. But I'm going to simplify this to I cubed over n to the 4th. And now remember, I only need to keep the I stuff after it. So the n to the 4th, that's going to move out here to the front as a coefficient. Still have the limit. But now I'll have 1 over n to the 4th, and then the summation of I cubed. And I have a formula for that. Hope you remember it. Which is n squared times n plus 1 squared all over 4. So that took care of all of this piece. And now I'm ready to do a little bit of magic. So these will all be gone. I'll have 2 left over. And then if I FOIL on top, it'll be that. And on bottom, I'm going to have 4n squared. Keep in mind this does still have the limit in front of it. And so now I can split it. So I have 3 pieces of numerator. So everybody gets a 4n squared on bottom. So limits for everybody. I'm so generous, aren't I? So I have n squared over 4n squared. And the next one I'll have 2n over 4n squared. And then I'll have 1 over 4n squared. And so now as n goes to infinity, I can use degree of numerator, degree of denominator. So the first one, since the degrees are the same, I could actually just cross them out. And I get 1/4. And then the next piece, the numerator's smaller, so that's 0. And the last piece, the numerator's smaller, so that's 0. So I get a grand total of 1/4. Yay! So before you copy me, I want you to stop the video and try this one all by yourself. Look back at the last one, and it should help you. Okay, so check your progress. Over on the right, I made a list of the things that I needed for my formula. Remember, I needed the f of x sub I, and I needed delta x, because that's length and width of my rectangle. So I made myself a little list here. There's my delta x, b minus a. Remember this time a is 1 and b is 2. And there's my x sub I, which is just the beginning, the spot where I started, plus a whole bunch of delta x's. And so I keep track of how many by I. And then if I want f of x sub I, I have to plug that in. So remember, this is really I over n. So there it is. I plugged in 1 plus I over n, and then I FOILed and simplified. So now I took f of x sub I times delta x. So there they are. Okay, so I'm going to get rid of those parentheses. By multiplying that out. See if you got that. And then I can start splitting them. So make sure you have limit on each of the terms. Make sure you have sigma on each of the terms. And then I can pull out anything that's not an I. And now I'm ready to start substituting in for all of my sigmas. Still don't get to throw away the limits yet because I haven't taken it. So this summation will be n. And then this summation is n times n plus 1 all over 2. And the last one is n times n plus 1 times 2n plus 1 all over 6. And so when I simplify each piece, this one's going to be 3. And here the n's will cancel and the 2's will cancel. So I'll have n over n plus 1 over n. Of course, this one's going to reduce to 1. And then the next piece will reduce to 0. And then over here, I can cancel. I'll have squared. And then this is gonna turn into 2n squared plus 3n plus 1 all over 6n squared. So I'll first have this piece, which will reduce to 1/3. And then I'll have the second piece when I split it, which will turn to 0, and that's because the numerator is smaller than the denominator. And then the third piece will also turn to 0 because the numerator is smaller than the denominator. And so I'm going to get a grand total of 2 1/3 or 7/3. Oop, wait, my bad. Did you catch the mistake? Remember I had this minus here, so I was subtracting all of this. So this would have been a minus. So I get 2 minus 1/3, not plus, which is 6/3. No, wait, 2, that's 6/3 minus 1/3, excuse me. It's 5/5. Ta-da!